This lesson is on organizing data. We're going to start by organizing data in a table. You probably have done this already. And then we're going to talk about how to organize data using a stem and leaf plot. Let's look at example 1. Use the following data to make a table. Josh and Abby swim laps daily to practice for the swim team. On weekdays, Josh swims 12 laps and Abby swims 18 laps. On weekends, Josh swims 20 laps and Abby swims 25 laps. It's not necessarily one right way to do this. I'm going to put the people down as rows and I'm going to put the weekdays as columns. So we are talking about Josh and Abby. I skipped the first corner because that's really the title for each row and column. So here we have weekdays and weekends. Now you're just plugging in the numbers they gave you. So on the weekdays, Josh swims 12. On the weekdays, Abby swims 10. Josh weekends 20. Abby weekends 25. Let's title our table here. What are we talking about? We're talking about swim laps daily. Again, you could have set this up differently. There's a good table. The stem and leaf plot might be new to you. Notice that the stem and leaf plot has a vertical line that separates section from another section. On the left of that line is called the stem. That is all the other digits of a number. On the right of the line is called the leaf. Those are the last digits of the numbers that you're organizing. So look at the example data. Make a stem and leaf plot for the following data set: 2, 5, 13, 13, 17, and so forth. You look at those numbers, and what you want to do is first order them from least to greatest. Second, determine what would make a good stem and what would make good leaves. The stems here are going to start at 0 because there are numbers that are less than 10. 2 and 5 have to have a stem of 0. But then 13 has a stem of 1 and the leaf is 3. 37 has a stem of 3 and the leaf is 7. So you list those values in the stem and leaf plot, and there's no commas and they're in order from least to greatest. If a number repeats, you do repeat it. You need a key down here at the bottom. We have a key telling somebody how to read your stem and leaf plot. And then we should title it. This one we weren't sure what it was about, but we'll put a title on the other ones. Okay, so let's try this. Create a stem and leaf plot for the following data. These are the finishing times of runners in a 5K race to the nearest minute. Okay, so the first thing I'm going to want to do is I'm going to want to organize this data in order from least to greatest. It'll help to keep everything straight. So the slowest number I see is 19 and 19, so I'm going to write it. And as I write it, I'm going to cross them out. The next lowest number I see is, 21, then 22. I do 2 at a time. I'm looking across, making sure I keep them in order. I've got 25 twice. Don't forget to list it twice. 26, 30, 30 again, 31, and 40. Okay, great. Now that I have them in order from least to greatest, my plot's going to be created a lot more quickly. I'm going to title this plot, what is this about? It's the finishing times of runners in a 5K race. My stem goes on the left. These numbers range from 19 to 40. So 1, 2, 3, 4. Now my leaves are going to go on the right, and you do not put commas in between, but now that the list is already in order, it's very quick. So we have 9, 9, 1, 2, 5, 5, 6. Try to evenly space them out. It's almost like this looks kind of like, oops, sorry, 30, 31, and 40. It's almost like this looks kind of like a sideways bar graph. I evenly space them. You can tell that there are the most number of values in the 20s range because that list is the longest. We need a key, so off to the side or down below, you need to take one of the values from your stem and leaf plot and write it as a key. So I'm going to write 1 and then the line and then 9. I almost always just pick the first one. And what does that mean, or what does that equal? This means 19. The key just teaches somebody how to read it in case they are not familiar with the stem and leaf plot. Perfect, this one looks great. A stem and leaf plot really shows all the data values and how they're spread out. So we can see that we have the most in the 20s range, and that there are very few in the teens range and in the 40s range. From this, you can really calculate whatever you want on these data values. So if I ask you to find the range and the mean of the runner's times, you still know how to do that. That hasn't changed. To find the range, you're going to do the largest minus the smallest. But from looking at the stem and leaf plot, it's very easy to pull those numbers out. Our range is 21. To find the mean, it doesn't really matter whether you use the list that you originally were given or you use the stem and leaf plot, but you're going to add all those numbers up. If you're finding the mean from the stem and leaf plot, don't forget to put the numbers back together. Like 1 bar 9 means 19. So you're typing in your calculator 19 plus 19 plus 21 plus 22. Find the sum, add up all the data values. I got 288, and divide it by how many there are to find the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so what is 288 divided by 11? Type that in your calculator. I got a mean of 26.18 repeating. Both of those numbers are repeating, and that is my mean. If you wanted to round to the tenths or class rule, it would be 26.2. If it's a repeating decimal, I like to use that Rapitan bar and just keep it exact. A back-to-back stem and leaf plot is really just used so that you can compare two data sets. I want to look at something right next to each other and have a comparison. It's the same idea, except that the stem is in the middle now, and you actually have leaves coming to the left and the right of it. I'll show you what I mean. Create a back-to-back stem and leaf plot for the following data. A pet adoption center has various breeds of dogs for adoption. Their weights in pounds are given below. So we'll say weights of adoption dogs. In a stem and leaf plot that's back to back, you're actually going to have a center stem right here. So each side is going to stand for something. I'm going to put the females over on the left and the males over on the right. So don't forget to label each side so that I know which one's which. Okay, to decide the stem, you have to look at all the data values. It is probably helpful if you put those data values in order first. Maybe you noticed something. Check it out, the females are already listed in order from least to greatest. So that's already done. The males are not though, so we would need to list them. The lowest that I see for the male group is 48, then 49, then 51, 55, 58, another 58, 59, 62, 68, and 70. Okay, so when we look at the lowest in both of those categories, they start in the 30s. I'm going to need a stem that has a 3. when I look for the highest in both of those categories, the highest females go up to 60, but the males go up to 70. So I'll need to make sure my stem goes all the way up to 70. So 3, 4, 5, 6, 7. That stem will work for both males and females here. Okay, so let's take it one at a time. For the males, you're just doing kind of a normal stem and leaf plot. The males are off, the leaves are off to the right. Now that they're already in order, it's very easy to list them in order from least to greatest, no commas. So there's nothing next to 3. I don't put a 0 there. If I put a 0 there, that would mean that there was a male dog weighing 30 pounds. There's not. So I leave the 3 blank. All right, so I have 48, 49, moving down, 51, 55, 58, 58, 59, moving down, 62, 68, and then moving down 70. Okay, I'll need a key for both sides. Let me do the females first now. With the females, you're going to list them in order from least to greatest. This is out from the stem, so it's kind of read in reverse. So I'm going to start at the stem. Here's the 3. I'm going to work to the left and write a 0 in front of it. That looks weird, but that's actually read 30. So there's 30, and then I'm going to put a 2 in front of that. You're reading in reverse here, and that's 32. Another 2. We're done with the 30s. Move down. 40. Remember, 04 means 40, not 4. 41, 41, 44. Okay, 52, 58, and then 62. Perfect. So the last thing we need is we need a key so that we can read both sides of this. So you're going to have a stem with double bars around it this time. On the other one, we only needed 1 bar. And in that case, the stem is to the left and the leaf is to the right. In this case, we're going to need 2. So maybe I'll do 3 with the 0 in front of it. And what does that mean? That means 30. And then I'll do the first one that shows up for the males as well. 4 with the 8 after it. And what does that mean? That means 48. So you have a title, you have stems, you have leaves, and then we also need this key. The key can be next to it, down below it, but it should be right there with the stem and leaf plot. It's teaching us how to read it. Okay, there's one more thing going with this problem. It says make an inference from your stem and leaf plot. What's an inference? What does that mean to you? Well, look at the stem and leaf plot. Is there anything that you can kind of conclude? Is there anything that you can come up with based on the evidence that's given here in the chart? When I look at this, I would say that male dogs tend to weigh more than the female dogs. An inference is what you just did. It's a conclusion that you have reached based on the evidence or the reasoning that you have. When I look at this stem and leaf plot, I can see that the male dogs have the male side has more dogs in this higher weight categories, 50s, 60s, 70s. And the female dogs, look, they have more up here in the 30s and the 40s. It just seems like male dogs tend to weigh more than the female dogs. And in French, it's kind of like an educated guess. It's based on reasoning, so you're not guessing. You're looking at some data, some information, and you're drawing a conclusion. You may have come up with something different, and that could also be okay as well. But you're just trying to analyze the charts that you have created.